Hello and good evening everyone. We are from Tutorial 4 Group 1 and we will be presenting our PBL, The Mystery of the Mammoth Mine, The Hidden Danger of Radiation. My name is Nurul Amal and I will be explaining the introduction. So the Mammoth Mine in Ranau, Sabah was once a major copper mine, but since its closure in 1999, it has become a serious environmental threat. Acidic water and radioactive waste from the site have spread into nearby rivers. Villagers have reported glowing streams, deformed fishes, poor crops, and health problems. This is likely caused by radiation spreading through acid mine drainage, which gets worse with flowing water and heavy rain. To solve this, we can use filtration, containment, and plants to absorb radiation. Most importantly, involving and educating the local community is crucial to restore and protect the area. That is all from me.
Hello, my name is Nur Akila binti Muhammad Zaini. Now let's take a look at the abstract part. So, our focus was on the contamination at the Mammoth Mine, specifically from radium-226 and uranium-238. These radioactive elements have caused serious water pollution and are linked to health problems in nearby communities. We look into how these contaminants move, especially through ion exchange and methylation, and explore how vital remediation, like using wetland system, can help control and clean up the sites. From our findings, these natural methods show how good potential, but they aren't enough on their own. Ongoing monitoring and stricter regulation, especially for radium-226, are really important for long-term success. The goal is to make the site safe again and build a self-sustaining remediation system without needing constant external support.
Hello, my name is Siti Zulalina and I will be presenting the methodology. For this study, a qualitative method was used to explore the hidden radiation risk at the Mammoth copper mine. No fieldwork was done. Instead, the research focused on analyzing secondary sources such as scientific journals, government reports, and credible news articles. These sources were chosen for their reliability and relevance. The data were examined through thematic analysis, which helped identify key issues like environmental damage, health risks, and lack of public awareness. This method allowed the study to piece together a bigger picture of the mine's long-term impact without the need for on-site investigation. The qualitative approach was selected because it helps understand complex issues that cannot be measured by numbers alone. By using existing information, the study aims to raise awareness and encourage further research and action on this overlooked environmental concern.
My name is Nurul Izzati and I will be talking about the result part. The table shows that high radiation levels near the Mammoth Mine and elevated levels downstream correlate with radioactive isotopes like uranium-238, thorium-232, and radium-226. Contamination exceeding safe drinking water limits in the river, especially radioactive isotopes radium-226. Acidic mine drainage likely facilitates the spread of these radioactive materials, potentially contributing to reported health issues in nearby village and significant ecological damage. Community surveys reveal widespread concern about water safety and a lack of understanding regarding radiation risks.
For discussion part, Maisara and Irfan will present it. I'm Maisara and I'll briefly explain the health and environmental impact of the radiation at the Mammoth Mine. First, radiation dose risk. At the tailing overflow site, radiation level can cause exposure over 50 millisievert per year, which increases cancer risk. Even low doses, like those at Crater Lake, can damage DNA over time and lead to long-term health problems. Second, water contamination. Radioactive isotopes like uranium-238 and thorium-232 are leaking into rivers and streams. This puts downstream communities at risk, especially those depending on the water for drinking, farming, and fishing. Third, ecosystem impact. Radiation doesn't just harm humans, it also affects aquatic life. It causes deformity in fish and disrupt food chain, which can lead to broader ecological damage. So overall, radiation from the mine pose serious risks to both human health and the environment. So now I will pass it to Irfan.
Hello everyone, so my name is Irfan, so I will continue. So the next one is physics concepts applied. So the first one is ionizing radiation. You can see that the high levels imply presence of beta and gamma emissions, which is the types of ionizing radiation capable of penetrating tissue and damaging human or animals' DNA. So the second one is radioactive decay, which suggests ongoing decay of long-lived isotopes like U-238 with a half-life of 4.5 billion years, which is the radiation hazard is persistent over time. And the last one is radiation shielding need. These findings emphasize the need for containment, possibly via concrete capping, water filtration, or by phytoremediation. Thank you.
Hello, my name is Muhammad Fikri Izani bin Muhammad Rudi. So, I am presenting the last part of this poster, which is conclusion. The mammoth mine in Sabah has been shown have significant risks to the environment and public health because of the radioactive contamination from isotopes such as uranium-238 and thorium-232. The mobility of these radioactive elements increased and spread to the local water system due to the acid mine drainage. There are many solutions that have been proposed, including engineering approaches such as advanced filtration systems, radiation shielding, and converting the mine into managed wetlands. An integrated approach combining scientific solutions, public health interventions, and community collaboration is essential to resolve the crisis and ensure long-term sustainability. That's all.